Well, if I can, okay, I guess I can start. So basically, well, you introduce my experience, and this is very related with this tool that I am going to present. Since I realized during the participation of this project about the importance of the data quality and how we can ensure that quality. So we have developed this tool basically to ensure or to check that the data and the digital object that we are creating as researchers are adopting or not the FAIR principles. I will try to introduce also the FAIR principles, but I guess most of people knows already something about that. So the work of this tool, the development, was developed in the context of a European project, the EOSC-Synergy, that basically wants to put in place different pieces for the European Open Science Cloud. One of these is promoting the EOSC high quality services that involve the software, the research software, ensuring the quality, and the services dedicated to support different scientific use cases. And also the fairness evaluation. That means that we want to ensure that the data produced within a scientific and research context is fair, as I will explain later. For that, we have involved different thematic services, basically addressing different scientific areas like Earth observation, environment, biomedicine, and astrophysics. In this project, there are 22 partners from 10 different countries involved. We are not forgetting about for example, the skill developments, since it is a very important topic to be adapted to this digital era, and also expanding the capacity of the infrastructures, and also with the alignment at the policy level, supporting basically the European Open Science Cloud. So one of the objectives of the European Open Science Cloud is to set up, to create an environment for data to be fair and to facilitate researchers and basically any people to access to enough quality data. So this is linked, of course, with the FAIR principles. Well, I guess you know something about this, but I would like to emphasize the importance and how we can translate the FAIR principles in a technical way. That means how we can check automatically that a data set or any digital object adopts or not the FAIR principles. As you probably know, FAIR means findable, accessible, interpretable, and reusable. To do so, to check that a digital object adopts these principles, we can check three big groups of, let's say, entities. First of all, the data, the digital object itself. Also the metadata that we can describe as the information about that digital object, the description, the different information that allow us to understand what is the digital object, and the infrastructure that put this digital object in place, let's say repositories, data portals, etc. At high level, as we are working with the Research Data Alliance in the FAIR maturity group, they propose 43 indicators to check if some digital object adopts the FAIR principles. And this is the list of indicators that we are trying to develop using the FAIR EVA. So I would like also to emphasize at technical level how we are translating, let's say, those indicators to specific technical metrics. Okay, so for example, to understand if a digital object is findable, what we need to do is to check if the metadata and the data are assigned with a global and unique persistent identifier, if the data are well described with rich metadata, and that kind of things, and if it is searchable in a engine and in indexer, etc. So this is the starting point. This is pretty high level, but we are translating this kind of indicators to technical checks, as we will see with the FAIR EVA. For accessible, the kind of things that we are checking is if the data and the metadata are retrievable using the identifier, using a standardized communication protocol. That means HTTP, an API, or more oriented to repositories like OAI, PMH, and other things like if the protocol is open, free, and universally implementable. And if the protocol allows any kind of authentication and authorization, that kind of things that are more oriented to the technical part of the repositories of the data portals. And I think it's important to understand this A of accessible. Interoperable, that the set of indicators that we started to use is, for example, the first one, that the metadata and the data use a formal, accessible, shared, and broadly applicable language for knowledge representations. That means things like control vocabularies, etc. And other things like, for example, if the metadata and the data include qualified reference to other metadata. And that means, for example, relationships between different versions of the data, if they are associated to a particular publication, and that kind of things is the things that we are checking. And finally, reusable, where we check things related to the license, if they, the data and the metadata released with a clear type of license, etc. So, well, one of the things of the FAIR principles is that they are, and the indicators, they try to be generic. That means that sometimes it can be ambiguous, or at least it can be interpreted depending on the context that you are involved. Let's say different disciplines, different research areas can understand different things about the list of indicators that I have read. Okay, so the thing is that we need tools to assess the fairness of the data and the digital objects that can adapt to different environments. Okay, so that's why we created the FAIR EVA, that means Evaluator, Validator, and Advisor. But basically, we try to implement the FAIR indicators provided by the Research Data Alliance and the FAIR Data Maturity Group. The objective of FAIR EVA is to be modular, scalable, and flexible. Modular in the sense that we have different components. I will show the architecture that can interact and can be, well, deployed for any case. We want to be scalable, since we are creating more and more digital objects that are being, well, created every day from different scientific disciplines. And if we want to check most of them, we need to create tools to be scalable and flexible, in the sense that they need to be adapted to different, let's say, contexts, different scientific communities, different research areas, different repositories, different data portals, different services. Okay, so the idea is to create a tool that can be adapted to different environments. So we started with a generic implementation that implements and checks and accesses the data via the OAI PMH protocol. That is a well-known protocol for data repositories. But we provide the mechanisms to develop new plugins to connect to different data services, to different repositories. So I will show the generic one, and then I will show you a specific plugin, and I will give you some ideas on how that plugins can be implemented. The idea for FAIR EVA is not only evaluate that the data produced by the data producer, researcher, etc., is or not fair, but also validate everything and provide some feedback and advice how they can improve the data that they are producing. Okay, so giving some tips in order to improve the quality of the data that are stored in a repository, for example. When we started to develop EVA, our target was, on one hand, for example, data producers, that researchers that are producing data, but also the administrators for repositories and data portals that can check that, well, they provide the proper environment to store fair data. So that is, we think that is very useful for them as well. And also funders that can check for specific data sets or digital objects produced under the context of one project. They could also check and evaluate if the data that are being produced in a project is or not fair, or what is the level of fairness adoption. The tool EVA is developed in Python basically, and it is divided into main components, and a REST API to work basically automatically, so you can launch different analysis just well, programming a script, for example, and it can be automated, and a web interface for, well, general researchers or data producers to check in a web interface how they are producing the data. In order to launch the tool, you have two choices. You can launch on standalone mode, but well, I recommend the Dockerized version because it is very, very simple for do so. Okay, we are working on EOSC-Synergy in different fair assessment tools. There are something available already, different tools that can be used. But for the development of EVA, we want to focus in different functionalities, and we want to check and to advise how the data and the metadata can be improved to be actually fair. So we are checking different things on a high level. But for example, for data on the digital object, we check if they use, within the context of a research community, if they use a proper format. Regarding metadata, we can check if they are adopting, for example, a community standard, and if it is machine actionable, if they adopted a proper format for the metadata, like JSON, XML, RDF, etc. And one important element is the use of persistent identifiers, for example, DOIs that everyone knows. And if they are provided by an accepted authority like DataSite, etc. But we need also to check different features on the repository or data service side. For example, if they provide an index engine to search the data within the repository, and if they provide machine actionable features like APIs, etc. And the idea is to integrate the EVA or to try to put in place any piece to be integrated in different repositories or data portals. So this is the look, how the web interface looks like. And if you, well, we have a logo, and the idea is to show the data producers, for example, some measurements about the fairness level of the digital object. So they can, as we will see, they can see different charts about the different fair principles, findable, accessible, interpretable, and reusable, and how are the metrics of each of the groups. And then they can deploy the list of indicators in order to get more feedback, more information about each of the tests that are being tested within this EVA tool. I would like to show different technical implementation as an example, for example, of different levels. For findability, one of the indicators says that the metadata should be identified by a persistent identifier. So how we translate this indicator? Okay, in this case, what we are doing is searching within a predefined list of potential metadata terms to identify the metadata. And this is something that can be configured. So we check, for example, within the list of metadata terms, we check the identifier term with the URI qualifier and any others. If we can check in this field, in this term, if there is a persistent identifier. and we can check if it is a unique first identifier, and if everything is okay, that test passed. Okay. For accessibility, one of the indicators said that the metadata is accessed through a standardized protocol. In this case, at technical level, what we are checking is if the protocol to access the metadata is enough, is open, etc. For example, we check if you can access the metadata using the OAI PMH protocol, or if it is over HTTP with a REST API, etc. For interoperability, we can check, one of the indicators says that the metadata should use knowledge representation expressed in a standardized format, what means, for example, control vocabularies. And so far we are implementing the checking of different control vocabularies, and we check the metadata if some of them are are representing some information within the metadata. And for example, for reusability, we check a list of metadata terms defined by a specific schema, if if they include some mandatory terms, etc. The idea is that all that checks can be configured and can be adapted to different research communities, for example. So regarding the architecture, we have, as I said, a modular system where let's say a normal user can access via the web interface, but every request goes through the API. So we are doing automatically a request, and we will get some answer that will be translated in a in a fancy view for the user to see if they have achieved the fairness goals. Okay, so we have running different services, the web interface and the API that are communicating between them. And on the back end, we implement different indicators at technical level. We have a generic implementation that implements the RDA indicators, but we can extend that generic implementation to access to different data services. One of them is one of the plugins that I will show, that is the digital CSIC, that is the institutional repository of my institution. But you can define new plugins for the service that you want to use, okay? If a repository or data service implement OAI PMH protocol, that's fine because it works directly. But if not, you can adapt to use a new data service. Okay, so let's start with the demo. I will alternate the demo with some slides in order to explain better, but just 1 second. Okay, so basically, the easiest way to launch the application is via Docker.
Fernando,
So,
we're noticing the screen. Now it's
okay.
good.
Okay. So so there are, I have put all the links on the slides, but there are a Docker image available to launch the free EVA. And basically, if you run this image, you will get the image. It will be downloaded, and you can run directly a container with all the applications. But if you don't want to use Docker, you can just clone the GitHub repository and install every requirement for making the application works running. And one thing that you need to do is to configure the application. You have a template that is a basic configuration file that you can use, and it will work with only this configuration file. But if you want to customize something, you can check the documentation in order to adapt everything to your case. Okay, and then, as I said, since this is a modular system, you can run the API on one hand, that is the fair.py, and the web interface on the second part. But if you want, for example, just running the API, You just need to run the fair.py. Okay, so let's check this. Okay, let's try with first of all the web interface. So this is running on localhost. So if you click here, you will see the web interface that well can be also customized. We are working on adapting the logos, etc., to be potentially customized by the final users. One of the things that we can do is to translate. So far we have Spanish and English, but potentially it can be also adapted to new languages. So in this case, we are trying the generic implementation, that is OAI PMH, with Zenodo. Zenodo, you probably know, is a repository where you, as European researcher, can put some data there. So it is quite generic, and you will obtain a DOI whenever you create a new resource on Zenodo. So the input that we need to put is, first of all, the persistent identifier. In this case, it's a DOI. Then we can check the plugin, the repository to work with. In this case, is OAI PM8, that is the generic implementation. And we will select the OAI PM8 endpoint, that in this case is Zenodo. Okay. So, and then we just need to run the test, and we will obtain, well, on parallel, what we can do is check the logs in order to see that everything is doing something. We are checking, we are running the different tests, and after all, we will get, well, basically a level of fairness, okay? So in this case, we are obtaining 49% of fairness. If we deploy this section, we can see the different tests, what we obtain. Findable is basically okay. Accessible, we can improve, but interoperable and reusable, it should be improved somehow, because we just get a 9% of interoperability. Okay, for findable, that is fine. We can obtain different things. We will get the indicator level. That means that some of the indicators are essential, some optional, and some recommended. So it's better to focus on essential. And we will get different information, like what means the indicator, how these are being implemented at technical level, and some technical feedback. In the cases where we don't obtain a 100%, we will get also some tips, okay? For example, if we go to interoperable, as tips, we can recommend to use different control vocabularies. We will provide in some examples on how they can be adapted to different cases, etc. We will provide more documentation about how the researchers, how the data producers can improve the data fairness, basically. Okay, one of the options is also export this to PDF. So that's fine to have a document where you can see everything and you can print if you want. Yeah, and well, the thing is, in this case, as we will see, that for reusability, okay, we can replace. This is how the PDF looks like. This is a report that you can also, well, share or whatever, and that's also, it's useful. Okay, so for reusability, if you check the metadata terms, you will see that actually the license is present. However, the configuration is not checking the metadata term that we want to check. And this is something that we will change. So remember that for this digital object, we have obtained 49%, and we will check later. because as I said, the idea is to be adapted to different cases, okay? So the configuration file that I mentioned before allows you to customize different things, okay? There is different sections where you can edit to customize your EVA deployment. For example, one of the things that you can do is to select if your EVA deployment is focused on one data services or more, okay? If you want just use EVA for your local repository, you can select only local and you will select the only plugin to work. Okay. However, if you want to support more data services, more repositories, you can include the information of the repositories to work with your deployment here on the repositories section on the config.ini file. Then what you can do is to customize any of the plugins that you have activated. Okay. And in this case, you can define different, for example, metadata terms to check different characteristics of your digital object. For example, you can define where on the metadata you should check if the digital object includes identifier. In this case, it's identifier. You can check which of the metadata terms should be included to, let's say, that the digital object is rich enough to fulfill the FAIR principles. Different things like where to check the accessibility of the data metadata, if they are including some control vocabularies where need to be checked within the metadata. We can also include the list of data formats that are supported by the community, etc. And if we check here, we are checking the metadata terms where the license type is defined. In this case, it's license. But if we check on Zenodo, we will see that it's not the right place to check, okay? Because if we check here, it's data set, no, it's the link core. The metadata term to check the license is rights, is not a license. Okay, so what we can do is going back to the config file, and then instead of license, we can change the configurations to check rights instead of license. Okay. And then, well, it will be restarted and we can launch the test again. And instead of 49, I expect to get a new value. It takes time because it's 43 tests to be performed. But actually, as I said, instead of 49, I am getting 56%, okay? Because in reusability, we have increased the number. And this is basically that because we are checking the right place where the information about the license is, okay? In this case, it's rights instead of license. So this can be customized in order to adapt to different research community, different metadata schemas, etc. Okay, so if you want to create a new plugin, you need to have the architecture in mind. And you need to know how your data service, your repository works. You need to know, for example, how the metadata on the repository or the repository on your data portal can be gathered. You need to know if a persistent identifier can be minted within your environment. You need to know how the data is gathered, and if your repository or your data service includes any repository, any protocol, sorry, for metadata or for data harvesting, like OAP Image and API REST, etc. Okay, and that is the things that you need to know to develop a new plugin. although the idea is to improve the plugin system to facilitate to new developers to launch a new plugin, so far you need to edit 2 of the files of the Fair EVA tool. That is those 2. I have included an example plugin just to be edited if you want to check some new plugins, and you can use it as a starting point to create a new plugin. I am going to show one specific implementations that works with Digital CSIC. Digital CSIC is our institutional repository at CSIC. And we have implemented a plugin that works directly with this repository system. So we have specific ways to access to the metadata within Digital CSIC, also to the data, and we exploit not only OA PMH, but also the Digital CSIC API to get the information that we need in order to know if the digital object is or not fair and what is the fairness level of these digital objects, okay? So we have a particular implementation for Digital CSIC that we can use to check some digital objects, okay? If we do it like this, where we can put here the DOI, in this case is a PID, we can select Digital CSIC as the repository, and we can select the OAPMH endpoint. And if I run the test, it will not work because basically I didn't configure the plugin. And if we will go to the Digital CSIC section, we will see that the configuration is not filled. So we will get an error, but we can try to do it again, configuring properly the section of Digital CSIC. If we check here, we see that basically Digital CSIC is in blank. Okay, so I have prepared the proper configuration. I can paste here, and then I included more information. This is different from the generic implementation of OAPMH. We have included specifically which metadata terms to check, also with qualifiers, etc., and it will enrich our application basically and our plugin for Digital CSIC. So we can save the configuration. The service will be restarted automatically, detecting the new changes, and we can rerun the test this time with the configuration. We can, of course, check the logs in order to check to see if everything is working or not. It is checking different things. It is running different tests. And after a few seconds, we will obtain a result. Okay. As I said, this works because I developed a new plugin for Digital CSIC. It uses, for example, the API to check the data itself, the data files that are in the, well, related to this identifier, and it checks everything in order to give us some information about the fairness level of this digital object. Since it depends on the API, sometimes it won't work properly, and it takes more time than expected, but let's hope that it will work. But basically, what we are trying is this. We get the metadata, we get the data using the API of the Digital CSIC, we check also different protocols like OAPMH, and checking all that information, we will obtain the fairness level of this digital object in particular. Okay. In this case, well, for some reason, I will recheck the everything, but it is not getting the persistent identifier. I don't know why, actually, but let's try to rerun the test in parallel. But in any case, you will obtain different technical feedback that allows you to understand what is missing or what can you improve. Okay. In this case, for example, if we check this data set, we can see different, well, interesting characteristics like the use of control vocabularies to define different things, the licenses using a proper format, etc. Okay. So, well, in principle, it should be better than 39%, but let's try to check again. Okay, but I am going to continue. As I said, to implement a new plugin, the easy way is to edit and to improve example plugin and the RDA one to include some information. You can find all the information that you need to deploy a plugin in the documentation. But I also want to show you that the EVA is not only the web interface, but also if you want to somehow use the engine to other purposes, you can use the API directly without using the web interface in order to make your own test. Okay, so instead of going to the web interface, you can use directly the API, just making some HTTP requests to the system. In this case, they are a running environment where you can just run, and you can get a JSON output with all the information regarding the tests. Okay, so it takes time. I don't know, but I think Digital CSIC is going slow. So if it takes more time, what we can try to do is to use Zenodo, for example. Let's wait 1 minute. It is taking a lot of time. I think it's, well, the problem is on the Digital CSIC side, I guess. So yes, I think we can try to test with Zenodo. Let me copy here the same information here. I'm going to restore the kernel. So instead of this can be configured, of course, we can use this identifier with OAI PMH plugin in this case. That is the same of doing like this. And we can use the endpoint of Zenodo to launch the test. Okay, yes, because I think there's some problem on Digital CSIC. So let's use Zenodo. And let's hope if they take less time to do it. Okay, so I assume it is running the test, so it takes a few seconds to do it. And okay, instead of receiving an output like this in HTML format, you will get a JSON output that you can parse whatever you want in order to get information of the tests. Okay, so for example, you can list all of the tests by the groups. You can see the list of tests for findable, for accessible, for interoperable, and reusable. You can know how the information is included for each of the tests. You can get a message that allows you to get some feedback, the name of the test, the points earned, etc. And you can do whatever you want with this output. I mean, you can get, for example, some statistic, or you can translate to a data frame if you know how to do it in Python. You can do some statistics like the mean of the points of your test, or you can plot the results on whatever format you want. In this case, a bar plot. And so you can use the Feriva as you want on the web interface or on the API directly. Okay, so let's go back to the end. Basically, we are implementing the Feriva. We have released the version 1, but it can be improved, of course. So we are trying to improve the plugin system to be more automatic and facilitate new developers to create new plugins. We will work on validate the plugins in somehow that they need to fulfill some requirements. Of course, any feedback is welcome. So if you want to use Feriva and you have any feedback, you can use the GitHub issues to provide us with some feedback. And we have the first list has a DOI that can be accessed, and everything is documented on our GitHub repository. And that's all from my side. If you have any question, we can check.